on this computer, and we're off to the races. Okay. So, obviously we're approaching December, which means we're approaching the end of the term here in a couple of 3 weeks. And so, you know what, we've covered quite a lot of ground, obviously, from what is system dynamics to now we're building an original model, sort of. I mean, this is a somewhat classic exercise, but everybody who does it a little differently. So my version is different from George Richardson's version, which is different from John Sturman's version and whatever, right? So it's sort of an original model. And what I'm trying to do is talk out loud to represent my thinking as I would be going along if I were doing this for the first time, to represent sort of the process of how you would go about doing one of these things. People find that if they do it beyond this class, if they delve deeper into system dynamics and really start building models, that they develop their own style of modeling, which may or may not look like mine. So this is a way to do it. It's not the way to do it, right? But it works for me. So for whatever that's worth. So having said that, let's, I just got to find my correct screen here. So bear with me.
And while you're doing that, I've got about another 30 minutes to finish up our video from last week. But, I really thought that was a good point that you made, demonstrating in the Kaibab plateau model, how, you, depending on your audience and who you're communicating with, whether you represent something that could be done as a table function versus a stock. And so much of your style has to be sensitive to your audience and feel like what's most impactful. And I guess that's what makes the experts the ones that really can engage, because they have the flexibility to modify their model to be something that can be grasped by their audience.
Yeah, because you want, in a consulting engagement, you want the client to feel that it's their model, not your model, that you're just the intermediary that's taking what they know and putting it into the system dynamics framework. And, it's not your model that you're trying to impose on them. And so it's tricky business to say to the client, I don't think that needs to be in the model because it's just overkill, too much, or unnecessary, versus they really want it in the model for comfort, or, so they believe it or they have confidence in the model or whatever. And then you end up putting it in because even though it technically doesn't have to be there, if they're going to use the model and believe it and learn from it, not just blow it off, that's an important part of it. And you find, well, in the case over here with this heroin model, if the client were the chief of police, you'd have a lot of police stuff in the model. If the client were the physician running the methadone clinic, you'd have a lot of methadone clinic stuff in the model. And if it was the mayor, let's say, the city council, you'd have a lot of political issues in the model. So it just depends who the client is, who the end user is, who the audience is, as to what you stick in and what you leave out. So therefore, 5 different senior system dynamics modelers can listen to the same problem statement or read the same article and come up with similar but often different, significantly different models based on their frame of reference, or again, who the client is or what have you. So, because again, the idea is not to produce a mathematically elegant, brilliant edifice. There's a work of mathematical art that can be admired, but rather to have the model tell you something that you didn't know that can be used to make the real system behave better, right? That's the bottom line. And then in some sense, you throw the model away after that. Who cares? Because now we've redesigned the airplane, the system, the heroin socioeconomic system or whatever, in some fashion, so that at least it's better. It might not be solved, but at least we've made an improvement in things. And the improvement hopefully is robust, so it just doesn't fall apart the first time something unanticipated occurs, right? So yeah, go ahead, Ashley.
Do you find that even though people are designing the systems very differently, that there showing the same insights ultimately, or that they're showing the same, you kind of end up with some of the similar conclusions about the system itself to help with that
Yeah,
policy.
so, right, so yes, so if you're trained kind of in the standard, I guess you'd say the MIT way of doing it, as they invented it, and that's where I learned how to do it, and anybody I teach kind of I was taught by Sturman. Forrester was there and he would lecture to us and walk around and say, what are you doing? And make suggestions and stuff like that. But he wasn't actively teaching. Sturman was actually teaching. And so I took both of his classes, and then I would sit with John in his office, asking him questions and building little models and whatever. And so my way of doing it is quite similar, but not exactly the same as John's. And my way of doing it is very different from Khalid Saeed's way of doing it. Having said that, we all know the same generic structures. And, you know, you all kind of know, okay, in this situation, it's likely this ordering function or something that we would use. And everybody would kind of grab the same chunk of well-known structure and plop it in into position. And, or there's, you know, if something is growing and it shouldn't be, you're likely to add a negative loop somewhere. You just know that. So it doesn't matter if you got a lot of law enforcement stuff in there or not, you're probably going to put in a negative loop somewhere, let's say, for a policy change. So, it's similar but different, but the models can be, you know, unique in the sense of representing different points of view. You know, what's important to the model. Even if you were doing it on your own, you might have different opinions than the person next to you as to what's important, right? So, but yeah, a lot of the principles are the same, and so you're likely to have similar conclusions when all is said and done.
Okay, that makes sense.
Yeah. All right, so so we read a newspaper article. This is a classic exercise written by a dude named Saul Friedman back in 1976. And he was talking about a report that came out using data from the city of Detroit. And it at the time, at least, presented a counterintuitive result that when the Detroit police are successful in seizing heroin and getting it off the street, the result is more heroin-related crime. And the thought process at that time is it should reduce heroin-related crime. And they tell you so a lot of times you don't know why that's happening. That's a curiosity. That's why you're being brought in. That system dynamics might be the right tool. We just don't know why this is happening. In this case, we know why, because when the heroin is seized, the shortage of supply relative to demand is the same. The addicts are still there and they still need to feed their habit. So more demand, less supply, basic economics, price goes up. $7 a bag to $9 a bag. It gave some data in there. And the addicts are poor. So they just can't open their wallet and say, who cares? It's $9 instead of $7. Here's a 10, keep the change. Either way, no, they can't afford it. And they live in poor neighborhoods. So when they go commit burglaries and robberies and such to raise the money to make up the difference, they have to do a lot of robberies and burglaries and things, because when you're robbing poor guys, you don't get a lot from each robbery. Right. So that's not a curiosity, or, you know, they kind of know, or at least the article seemed to know why it's happening, but it doesn't say anything about what to do about it. Right. So herein lies, because I mean, if it also knew what to do about it and they're doing it and it's working, there's really no need to have system dynamics involved. Right. So that's really the curiosity. All right. So, or the thing that's motivating the modeling intervention. So the first thing you do, just to reiterate from last time, when you, or at least what I do, is when you go in to a system dynamics modeling intervention, is ask, well, why am I here? What is the question, the curiosity, the problem, the thing that's going to motivate the modeling study. We don't want to model the system, try and make a digital twin of the real world, which you can't really do anyway, I don't think, but it's a popular idea today, digital twin. We're not trying to do that. We're trying to model a problem from a systems perspective. We're not trying to build the mother of all models of Detroit or the Detroit criminal system or something to answer all questions. We have a very specific problem here, and we're asked, what to do about it. And it's a common problem when you have illegal activities, whether it's drugs or guns or prostitution or what have you. Do you fight on the demand side? Do you fight on the supply side, or some mix of those with your limited resources? And exactly where do you fight on the demand side or on the supply side? Okay. So based on the article last week, we came up with the following statement here that's on the screen. What do we do about the fact that when the police are successful in seizing heroin supplies, the result is more crime? Okay, so presumably the answer is don't seize the heroin, let her roll. Presumably there's some other answer here. Okay, so it depends on how you do things. The next technical step, like if you were listing the steps in the classic system dynamics modeling process, the next step would be to specify the reference mode, which would be to take that sentence that's on the screen there and turn it into a dynamic picture of time shapes and relative time shapes, not just the time shape of this and the time shape of that, but relative. When this is going up, is this going down? Is this peaking before this one is peaking? This sort of thing. But in order to draw out a reference mode, you first have to know what variables you're going to be graphing, right? And I find a useful way of trying to identify the important, because we're not trying to model everything, just the important stuff important to this problem statement, right? I find it useful to think about starting with a sector diagram. And we talked last time about what do we mean by a sector diagram, and I think I showed you one that based on a model we did for Oxford Healthcare and their loss of membership, right? And one we did for the battle between zero emission vehicles and internal combustion engine vehicles in the early 2000s, right? So think about a sector diagram as you're in your conceptual helicopter hovering above your model, as though you're flying in an airplane and looking down on farmland, and you see the parcels of land with different colors, and they're kind of stitched together. Each of those parcels of land would be a sector of the model, right? And they're going to interact with one another, right? So over here, again, returning to the screen, we had letters of the alphabet here. But the A was for addicts and the D was for dealers. And I said another thing I personally find useful, and this is when I put on my economist hat, is I think in terms of supply and demand. I can't help myself. I mean, that was beaten into me since 1976. Supply and demand, two lines crossing at a point. But it's often useful, not always, but it's often useful to try and think about, is there a supply and demand thing happening here as well? If you're modeling a university, right, the suppliers would be the faculty, the administration, the plant and equipment that make up the campus and so forth. And then the demanders would be the students, the undergraduates, the graduate students, maybe the parents, and so forth, right? So it's just helpful often to keep that in your hip pocket, maybe thinking about supply and demand when you're thinking about the sectors in your model with the zero emission vehicle versus internal combustion engine vehicle. The demanders are the people in the market for cars, and the suppliers are the ZEV dealers, producers, and the ICE producers, and so forth. Okay. So with that in mind, we started brainstorming last week about what we might do for sectors. So addicts and dealers, supply and demand. There's a government sector here. I think we had a law enforcement sector in there somewhere. And we probably had a medical sector in there that looks like a T. What do you remember what T was? I don't recall what we said. Anybody?
I don't remember. We did talk about law enforcement.
Okay.
So maybe that.
Right. And then kind of the medical methadone treatment kind of stuff. So I don't remember exactly what, but we didn't come up with 17 different sectors or 95 different sectors. We came up with a modest number on the order of, let's say 5 sectors or something like that. And this is just brainstorming. We're not carving this in a stone here, right? We're just saying, all right, we're doing some spitballing here. And what I would say is always good. Brainstorming is good. Let her roll, particularly if you're working with clients. You got a room full of people who have been doing it every day, all day for many years. They got great mental models. You let them talk. You let them, when you say, what sector, what's important here, and you want to get it out of them, because and a lot of times it's not bizarre. It's usually pretty tight. They can tell you, well, there's the marketing department, there's the shop floor, there's the accounting guys, and they can kind of tell you how that works. Okay, so what I would recommend in this case is if we had 5 sectors, 9 sectors, 7, some modest number, say, all right, let's pick 1 or 2, and we can always add to them later. So what I'm going to do is I'm going to get my eraser out here, and being an economist, I'm going to stick with the supply and demand stuff. That's just how I think about it. There's nothing sacred about that, but we're talking about the addicts and they're committing the crimes. We're talking about the dealers' heroin being seized. So it would not be ridiculous to say those are legitimate sectors to start with. Again, there's nothing in the rule book says it has to be those. But that's where, like I say, I can't help myself. When I finish brainstorming, I kind of say, all right, in light of this, I usually will start with a supply demand thing. And that just is too many years of doing econ, I guess, or something. But you know what? It's probably best. It's probably just do it. This is going to take forever. Let's just redraw it. Might be the easiest way to do this. I think pen here. So we had the dealers, and then we had the addicts. So there's your supply and demand, and they interact with one another. And there's other stuff. We acknowledge that. We'll get to it when we get to it. Okay, but this is a good place to start. Okay, so now, again, I'm after a reference mode. I want to turn that problem statement into a dynamic picture, right? Because we want the base run of the system dynamics model to mimic or look like the reference mode, look like the problem statement, and then therefore offer an explanation for why the problem is occurring. Okay, so we would want to think about what variables would be in either of these sectors that we could graph that would present a picture of the problem statement. Okay, so we got dealers and addicts. Okay, and we also want to remember the problem statement. There's drug seizures. Heroin goes away, maybe not entirely, but a lot of it goes away. Heroin price rises. This is noticed by the addicts, who they can't just say, oh, it's higher price, so I'll substitute vaping or something for the heroin. No, you need what you need. Got to pay the higher price. They're poor. They have to go get the money somewhere. The crime rate goes up. Okay, so we're bearing that in mind. We got a couple of sectors here that seem to be important, kind of at the heart of the matter. So what would be some variables residing in either of these sectors that we would graph potentially to make a reference note. Does anybody want to offer any suggestions? Sticky note. I don't want sticky notes. Where's this? Oh, here.
You're gonna want heroin, a stock of heroin.
Heroin inventory. That's would be a stock. Whose inventory?
Well, I think that's gonna be the dealer's inventory.
Okay, the dealer.
I guess there would be two heroin stocks, one that's associated with the dealer and the other one that's associated with the addict.
Sure. So the addicts would have a stash.
Yes.
Presumably you don't buy it immediately, use it, it's gone, and then you wait until you need it some more, and then you go buy it again, use it, it's gone. Presumably you have enough for several helpings, whatever fixes, whatever they're called.
Oh,
And-
that, if I smoke heroin or anything like in my house, it's gone immediately.
All right. So, but again, so if we were really doing this, we are really doing it, but if we were really doing this, we would be asking these sorts of questions to experts, right? I mean, truthfully, I don't know the answer to that. But somebody who, a drug enforcement officer would know the answer. People at the methadone clinic would know the answer. Addicts or former addicts, you could interview them. They could tell you, right? Often you get a lot of insights from folks like that. Okay, so in heroin inventory, so that would be kind of the supply, right, of things. What else? What else was in that article?
I mean, you could potentially, I don't know if this is in the article, but you could put something in there about the level of addictiveness of the heroin, because that would drive the addicts back to the dealers and drive the demand.
So you mean like the purity of it, or when you say level of addictiveness?
Well, I mean, different drugs have different kind of addictive qualities, but heroin in particular is physically and mentally addictive. So like if you don't have it and you have had it for a long time, you could die from the withdrawal. So there's sort of a level of desperation, with that. I'm not entirely sure what we call that, but like level of desperation, level of addiction.
Is it dependency?
Or
Physical,
dependency.
psychological, is that the word they use?
That sounds right.
Okay. A profitable way to think about what variables would be important residing in either of these sectors is to always refer back to the problem statement. So, it's the problem statement was, in some sense, was in the title of the article, right? When heroin supply cut, crime rate goes up, right? So we have heroin supply. When heroin supply cut, how does it get cut?
Because law enforcement is seizing it.
Heroin seizure rate.
Mm-hmm.
Okay. So when heroin supply, we got that, is cut, we got that. Crime rises. What else? Just based on the title of the article.
Well, I mean, I guess there's also the cost of the heroin, which is tied to the inventory and the demand, which would
Heroin
be
price, the article talked about it going from $7 to $9 a bag.
Mm-hmm.
And when it does, what does the title of the article say?
Crime increases. So
in some sense, these four variables here kind of tell the story, or would be part of a picture of the story. You have heroin, some of it is seized, so the supply goes down, the price goes up, and the crime rate therefore goes up. Right?
Right.
Okay. So the dealer's heroin inventory is probably in the dealer sector. The seizure rate is probably over here. Price, I think the dealer set the price, not the addicts, and the crimes are created by the addicts. Okay, so we have, it's probably 3 variables in each sector, something like that. Right? Agreed?
Agreed.
Okay. Anything else that, based on the article, would leap to mind as being very important to the problem? We're not trying to put everything that's in Detroit in here, or in the Detroit criminal system in here. We're just focusing on the problem statement. Or is this good enough to get going here?
Well, I mean, at this point, would you put in the fact that the law enforcement policy affects the heroin seizure rate? So that would be
Well, okay, so what I would say to that is maybe. First of all, we don't have a law enforcement sector up here yet.
yeah.
So we could say if and when we add that, we can consider that, number one. Number two, who's the client? Is it the chief of police? Then we might even be having the police sector up here first, right? Because the chief is paying the bill.
Right.
So it really depends on who's the client, what are you doing? Sometimes you got to read the room, and you got the experts in the room, like who's in charge here, even if nobody technically is. Sometimes it's Mr. or Ms. Influencer can carry
Right.
the. So it all depends. But so I think we got enough here to get going. So what I would do at this point, typically, well, there's a couple of things that you could do at this point. You could say, all right, I got enough here to start making drawings. Okay. So is that, yeah, that's the eraser. Okay. So now I'm gonna, probably should just delete the whole thing. It's probably quicker, but let's just use the eraser here. I just want to make some room here.
What are you working in, Mike? Are you using the whiteboard in Google?
Yeah, a Jamboard or something. I think it's going away. I think Google is going to stop supporting it. But yes, currently. So it's very hard to draw with a mouse, I find, or write with a mouse, but it's the best tool at the moment. So I don't know if you can use a stylus with this thing. Maybe. I don't know. I haven't gotten that far yet. But at any rate, at this point, I would say there's probably enough info to begin trying to specify a reference model. Now, if you remember the couple of diagrams I showed you when we were talking about time shapes, system dynamics modeling, we parsed the phrase when we were doing dynamics. And Jorgen Randers had a diagram, Forster had a diagram, Khaled Said had a diagram, all indicating that modeling is an iterative process, right? So we don't, whatever we do here now, we don't carve in a stone. We can circle back to this and revise it later in light of new information or simulations start to tell us something or whatever. But we got enough here to get going. So, all right. So I would draw a Cartesian plane at this point. Right? And we're going to put time on the horizontal axis here. Now, from the article, what do we think about time? What units are time in, do you suppose?
It was in years. It was like 1970 to 74, right?
Well, it's a little murky, but they did mention in particular a unit of time? Remember?
I thought it was years, but maybe not.
So mention months. Okay. So one of the things you're going to be doing with a reference mode is, well, we have time on the horizontal axis because we're doing system dynamics. What do we mean by dynamics? What are our units of time? So months, now, again, we're not carving this in a stone. We might change our minds later, but the article did mention months. So, okay, we'll start with that. So what is the causal order from the article of the problem? What's the first thing that happens to trigger the problem statement?
A seizure, a
Okay.
drug seizure.
Okay. So heroin supply is seized. Now, one of the things about drug seizures, based on I've never been a drug lord, but based on my watching of movies of drug lords, TV shows, my observation is that what the police do is they gather data for a while on the drug activity in their neighborhood, in their precinct, whatever. And they wait until they have a lot of intel that they're going to get a good haul of stuff. Seize a lot of heroin, a lot of guns, a lot of money, arrest a bunch of people. And they coordinate. There's usually more than one drug den, right? And they don't want to just do the first one and then they quickly call and say, run, hide the stuff. The police are. So they all coordinate, with cell phones and radios and stuff. And it's, on 3, 1, 2, 3, boom. And they take that battering ram thing and they come storming in and they arrest everybody and what have you. So by the very definition of what I've just described, it's a shock. It's a surprise. The bad guys don't know that this is coming. If they knew it was coming, they would hide the stuff, right? So every once in a while, you see the movies where the officer thinks he's got them and they crash in and there's nothing there. Or I'm thinking of, there was an old movie with the Rat Pack. Ashley doesn't know who the Rat Pack was, but it was Robin and the Seven Hoods. You don't remember that movie, Suzanne?
Yes, of course.
And it was a spoof on Al Capone in Chicago during the 1930s and Prohibition. And they were tipped off when the police were coming. And so they had this button and they'd push it. And the bar, the speakeasy, everything would rotate around and the walls would go up and whatever, and would turn into a temperance movement. And as soon as the cops would leave, the walls would turn around and go back to gambling and drinking. So if they know you're coming, they're going to hide the stuff or whatever. So it's a shock. Now in system dynamics, we looked at how do you shock a system out of equilibrium, right? Now we did that in the context of testing model structure, and it's absolutely important for that purpose. But in this case, if something is a shock that knocks the system out of equilibrium, there's a suddenly there's something that happens in the Middle East. Suddenly a tanker wedges itself in the Suez Canal and disrupts supply chains around the world. Suddenly there's an orange crop freeze in Florida. Suddenly there's an interest rate change in some central bank somewhere, not anticipated, right? And then the system has to respond to that sudden shock, okay? If that's the case, I'm inclined, this is just me, to think about starting the model in equilibrium and then shocking it out with whatever event is in question. In this case, it would be a drug seizure, okay? So we got heroin inventory, dealer's heroin inventory. That's going to be seized, right? So if we're starting an inventory, we're going to have a horizontal line. And then at some point, bang, surprise, the police come and they're going to seize the heroin, right? So when it gets seized, the amount is going to drop, right? Probably not to zero. We're not going to get everything, right? And then what happens over time? well, let's go one step at a time. So there's a drop in the dealer inventory. So that's in red here, right? And it drops because there is a big spike in seizures. Now, the scale is different for the green and the red. They're not on the same scale because otherwise you'd have a lot of, depending on the various magnitudes of the numbers, it would be something that happens. You can barely see it because the other number is swamping it. So they're different scales. So there's a big seizure. Okay. And the heroin inventory goes down. So the seizure rate, we'll call that in lime green. Okay. So what happens next? So there's some sort of crime rate that, excuse me, heroin price, sorry, over here. And again, starting in equilibrium, meaning there's some sort of normal price, normal seizure rate, normal stock of heroin. They're always seizing stuff. They pull somebody over, they frisk them, they find what you see in the cop movie. What's this? And they pull the bag out of their pocket and, oh, that's enough that's more than an ounce. You're a dealer. You're looking at, 10 years in prison. So not immediately, but a little while after, what happens to the price?
Goes up.
Goes up. And probably what we're looking at is not so much heroin price going up, but the price quoted to the customers or perceived by the customers. So it's going to take a little while for the price to disseminate to the hinterlands, right? The drug dealers have to regroup. The lieutenants or the sergeants take over because the capos or the head people were arrested, right? And they're regrouping. What do we have? Who do I have on the street to sell the stuff? What have you? And then the word has to go out that, hey, we're short of this stuff, so the price is going up. So the price perceived by the market is gonna go up after a little, probably not that length of time, but probably not instantly, right? It's probably after a little bit of a lag, the price is gonna start to go up. Again, different scale here. What happens next?
The crime rate increases.
Yeah, so the crime rate, there's some normal amount of crimes that are happening on a daily basis, monthly basis, let's say. And of course, as the price starts to go up, price perceived by the addicts or quoted to the addicts goes up, they're going to have to start committing crimes. Again, maybe not exactly, maybe, I'm drawing this by hand, it's a little hard, but exactly what the lag is, I'm not entirely sure, but okay. All right, now the drug lords, the people up the supply chain, for example, start to say, we can get a higher price for our stuff in that neighborhood instead of this one. So they say typically, let's send some product over there. So what do they start to do? They start to regroup and they start to replace and get back to where things were, right? The seizure rate typically will go way down. Why is that?
Because you just got a bunch off the street, so now
There's nothing to seize. You can get it all, but it's like the deer density thing on the Kaibab Plateau. When there's deer everywhere, it's easy to get them, but when there are very few left and they're hiding, it's hard to get it. So it doesn't go to zero, but eventually it'll start to recover, going back to presumably where the average or typical level where they're not doing a big raid. They're just getting people during traffic stops and whatever, right? And as the heroin is coming back, what's happening to the price? So it's going to start gradually going back down to where it was. And of course, then your crime rate is probably going to kind of follow that, right? So it's probably going to look something like that for a one-time seizure, right? Now, the cops don't just do it one time, they would do it again. Probably not immediately. It takes some time to gather the information. The snitches, the informants have gone underground or fled or whatever. The stuff is, you don't even know who's in charge anymore because you arrested the big shots. So now there's lower level people are taking over, or new big shots are coming in from out of town. You got to figure out who they are. So there's probably going to be a period of quiet where everything's back to normal, where they're gathering the intel and whatever. And then at some point, it's going to happen again. Right? Okay. So agreed, or is there?
No, that makes sense. I
So
want
it kind
to,
of tells the story, really was
Yeah.
in the headline of the article, right? Now we could put some numbers here. I haven't, but we're told in the article that this is like $7 a bag, and it goes up to $9 a bag. And the crime rate, I think in the article, it said it was at 11,000 per month. And it went up to like 12,000 per month.
that
What?
incidence of crime, like murder, theft,
No,
or is
heroin
it,
related crime.
so is that theft? It's not crime
It's
process.
burglaries, robberies, and robberies when you're,
To get money.
yeah, it was maybe it's assault or robbery. I can't remember. There's like 3 things the article said.
Okay.
So you had like 1,000 per month increase for a $2 rise in the bag of heroin from the article. So there's some context, like the scales here, we can kind of, there's a little bit of information. And again, if we were really doing this, we would be talking to police officers. How much do you typically seize, right? How long does it take you to gather the intel, stuff like that. Do you notice how we took care in defining not only the time shape of each of these variables, but their relationship to one another, their dynamic relationship? One peaks before the other peaks, that sort of thing, right? Okay.
So if you were gonna draw this, would you label the y-axis? Or and is there a name for this type of graph drawing?
This is,
Yeah, you'd certainly label it. I mean, this is obviously hand drawn in real time with a mouse. If you were doing it at your desk, you might have taken notes and done this sort of thing with a group of experts, police officers or whatever it is, and then gone back to your office and made this nice, and then at the next meeting show it to them and say, do I got this right? This is what I heard last time, and Sally, you said this, Johnny, you said that, and I've tried to capture what you're telling me, and you gave me an article about the data, and this is what, if they had actual crime data, there's no need to hand draw it. You say, well, give me the data, the numbers, right? And you might have to smooth it or something if it's noisy or whatever to determine the basic, time shape. But yeah,
would you consider this a reference mode that you've just drawn? Would you classify it as that?
yeah, this is a reference mode. Yes.
Okay.
So what we're after is a picture of the problem statement, right? So based on whatever we are told in the article or whatever our clients are going to tell us is the problem, we want to depict it in terms of its dynamics. Okay. So in some sense, we could assume at this point, even the number of addicts is constant. Doesn't mean you're going to carve that in the stone and say that the level of addicts is always constant in Detroit. No, of course not. But you could assume for a first cut of a model that the number of addicts is constant, right? Because I don't see any addicts changing over time here. Now but now, you know, somebody who does this every day, all day might say, no, that's very important. We need the dynamics of the addicts in here, because when the price goes up, they go to another neighborhood, the number of addicts goes down, or, you know, who knows what, right? So again, we're just doing this based on a very short newspaper article, but
And that might be something that's dependent on your audience too, right? Because if you were talking to like addiction prevention specialists, they'd want to see that dynamic piece. Whereas
yeah,
so
no doubt. And also when they see this sort of thing, as opposed to just talking, it gives them something to focus on, and they'll tell you how you got it all wrong. And they'll help you fix it. Right.
Yeah.
So, but you start with, you take a first step and you attempt to capture, like, you know, I always say, what I'm hearing here, what I think you're telling me is this. Am I right? Or am I misunderstanding you? Or I'm emphasizing something I shouldn't be, or whatever. And think about it. Folks who do it every day, all day can tell you, right? Because they know the system. Right. So even if they're not your client, even if you're just doing it for your doctoral dissertation, but you're interviewing experts to help you, they know a lot about whatever it is. Like my first doctoral student at WPI, Shelley Friedman, looked at pavement management. So it was a weird story, sidebar. So he was a dentist and he was a avid skier, and he had a horrific skiing accident, and he wrecked his back where he could not hunch over a patient all day doing dentistry anymore. So he had to give up his dentistry practice. So he took an MBA and became a professor of healthcare policy down in Connecticut. And all was good until a new dean came in and told him, you don't have a PhD. If you don't have one in like 3 years, you're gone. And he didn't have tenure. And he's like, well, I am a doctor of dental sciences. I am a doctor. And the dean said, I don't care. You're not a PhD. So no PhD, you're out. So Shelley had heard about system dynamics, and he contacted us, and he wanted to do a PhD. And so we were like, well, you know, you could go to MIT, but if you want to do it with us, fine. So up he comes. So he was interested in, I'm trying to remember what he was originally interested in. Whatever it wasn't what he ended up doing for his dissertation, because he had to be an interdisciplinary PhD student. So what that meant was we had to get a committee for him consisting of 2 professors from another department that had a PhD program, and then 1 or 2 professors from our department. So we got Guillermo Salazar and Rajiv Malik from civil engineering to be on the committee. Why? Because Guillermo had done his PhD in civil engineering at MIT, and he had taken some system dynamics and liked it. And Rajiv was on the committee because he was a young, untenured assistant professor, and Guillermo wanted to teach him how to be on a PhD committee. So Rajiv did whatever Guillermo told him to do. So Shelley came in and said, I forget what it was. This is like over 20 years ago, so I don't remember what, but he came in and basically, I would like to do da-da-da-da-da. And I said, fine. And Guillermo said, oh, no, this is an interdisciplinary PhD program. So you've got to have some kind of civil engineering thing going on here as well. You can't just, you know, do the one discipline, system dynamics. And so Shelley's like, well, what do you mean? I don't want to do, I'm not a civil engineer. I don't care about civil engineering. And Guillermo was like, I don't care. You want to do your PhD in the, you know, here at WPI interdisciplinary, you got to do something. So Guillermo made him take 2 courses in asphalt creation, asphalt mixing and asphalt recipes and all this stuff. And Shelley was out of his mind. He was going to sue WPI, blah, blah, blah. And I said, Shelley, you can go and sue the school, but you will never get a PhD from here if you do that. You will burn every bridge. I said, or take this 2 stupid asphalt courses and we'll figure something out. So he ended up calming down and he took the courses, and he ended up doing pavement management for his dissertation. And there were a lot of jokes about filling potholes, filling cavities in the teeth, as you might imagine. So at any rate, it ended up being a wonderful dissertation because the question he asked for the dissertation was, or the statement was, the promise it was, pavement managers will always tell you, if you give me more money, I can do a better job. And better was defined by fewer potholes, safer roads, and less tying up of the roads when you're repairing them, right? So in other words, if you pave a road cheap, it's going to just break down quick again. If you pave a road good, it's more expensive. But the better the road, the more people take it, and then they beat it down quicker. If you want to pave it good, you got to grind it all the way down to the base and you tie up traffic way longer. If you want to do it quick, you just squirt some of the stuff in the cracks or do a surface coat. It's way cheaper and it's way quicker. But it's more safe if it's paved well as opposed to you just kind of half-ass it. So Shelley asked the question, okay, yeah, if you have more money, you can do a better job. What if you have the same money, but do things differently? Can you do a better job? Better is tying up traffic less, better quality of roads, safer roads, and whatever. And that's what he did for his system dynamics model. And, but here's my point. I had him go out and interview pavement managers at both the state and local levels, both in Connecticut and Massachusetts, and say, they know, they do this every day. They know what's going on, and they can tell you what's important, what's not, what their pressures are, and what have you. So in the end, he was very happy. It was a really great dissertation, and he got interested. The Air Force was interested in his dissertation because they said that's what we do with runways. We wrestle with that exact problem. So anyway, all right. So we talk to experts who do things every day, all day. You can go interview them. You don't have to have them in a conference room. Shelley would drive to Connecticut to the state highway department and talk to them. And he'd go to the city of Worcester and talk to the DPW guys and all that stuff. Okay.
I have to tell you, this is what my younger son does and is doing right now in Highway 69. The paving crews are the bane of his existence. And when we drive around places, he'll go, these morons, see that? And he'll point out all the stuff that's wrong with it. And then he's got to go make the DOT happy and all of that. So that's just really funny. I may show him this video when he comes home.
Yeah. So yeah, no, it's a common problem. It's everywhere, and including in the military. So Shelley ended up loving it, but at the beginning he was like, asphalt mixing, what the hell? I don't want to know asphalt mixing. We wanted to do like systems thinking in healthcare management or something. He ended up doing asphalt, road paving. And then, all right, so at this point, I would say, all right, we have enough starter dough here to make a beginning. Oh, another thing before we do that, another thing that we would commonly do is start to ask the question at this point, what does better mean? What does solved mean? What does improved mean in whatever system we're working on? So what you find out is rare for a system, a complex system, to have, the red line is growing, it's growing exponentially, and it's bad. And when you do this, the red line stops growing, it starts shrinking. That's good. And it's blatantly obvious what is improved and what have you. I mean, that's nice. And if you can find that, hallelujah. But usually the attributes of a complex system that are relevant, are important, are many. And you find you get trade-offs, not solutions. If you want more of this, you get less of that. If you want less of that, you get more, this sort of thing. So we often, in this sort of situation, we say, well, we just make the orange curve flat. Okay, that would be probably, all right. Or make it less, maybe not flat, but lower, less heroin-related crime. a single attribute scoring metric or measure of goodness. But often it's multi-attribute. What makes a good city or good town? Low taxes, good schools, low crime rate, lots of open space, attentive government, whatever, opera houses, whatever you're into, right? And if you want a lower crime rate, the police chief says in the budget, I need more officers and another squad car. And then the mayor says, all right, we'll take the crayons away from the kindergarten kids to give you that those officers in the squad car. But then the school head says, you're going to trash the schools if you do that. If I don't have crayons and whatever, substitute teachers and whatever, now the goodness of the school system is going to go down and you'll probably have more crime. Because you got idle kids slashing tires or whatever. I just made that up, but you get the idea. So there's usually trade-offs. So we try and define often at this point what's better, improve, good mean, solved if that's relevant, and then what might constitute a multi-attribute scoring mechanism. Okay. Now, in this case, we're going to have a single scoring mechanism because we're just learning. We're going to make it simple, and that we're going to try and make the orange line lower. The policy mix that yields the lowest number of heroin-related crimes will be deemed the best. But it's usually not that simple, right? Usually you have a lot of trade-off. So then you start to say, really, it's a value judgment. And it's not just, we got to mathematically smear together 11 attributes defining a good city or whatever the thing is. What are the weights you attach to each of these attributes? Are they all equally important? Or is something as A more double the importance of B? You see. So this usually freaks out the engineers because they don't like math things that don't have an exact answer that's correct. Like 2 + 2 is 4. Anybody who gets 4 gets it correct and they get an A. Anybody says it's 5 or 3 it's incorrect and they don't get credit or they don't get full credit. That's what they think. Homework equals math problem with an exact solution. And when you say, who's your client? What better means or improve means depends to a large degree on who the hell's paying you. And there's trade-offs. There's not one optimal answer usually. That bothers a lot of people. They like a tight intellectual solution that says, do this, and that's the answer. And it is rarely so. Okay. So again, in the brainstorming session, the facilitation session, you're working with experts and stakeholders, try and get them to answer that now. I mean, I did a consulting engagement years ago for out in Reno and Sparks, Nevada. They're sister cities. They abut one another. And I had academics, professors and graduate students from the University of Nevada at Reno. That's their main campus. I had in the room, I had politicians and their staff in the room. And then I had the real estate developers who wanted to build on every inch of open space in the area. And then I had Truckee Meadows Tomorrow, the sustainability group in the room. And the people in Truckee Meadows Tomorrow wanted to exterminate the real estate people and vice versa. They hated one another. The politicians were trying to figure out politically, what should I do here? And the academics were taking notes on everything. They want to write a journal article, right? How do you facilitate that group of people, right? And I didn't know I was getting into it. They said, well, come and build a model that will help us reach a consensus on what to do here. I was like, whoa, these people want to just strangle each other. They're not helping each other. My point is, depending on who the audience is, it can be really tricky business to try and reach a consensus on something, to get them to tell you the truth, or they just won't agree, right? They just absolutely disagree with whatever is being said, and nothing you can say will change their mind. Yes, Suzanne, go ahead.
So who's paying you, and how do you not be catering to whoever is paying you?
Well, you try to be objective, but are we ever in this world? You know, you do your best to not just there's an old joke, you know, what's the first question a consultant asks the client? What answer do you want? You know, it's like there's a lot of that, I suppose, that goes on. So you try not to, but you're
Could you do something where you say yes? I mean, let's say you get burned once and you go, okay, I'm not going to get trapped in this similar situation again. Could you do something where you say, hey, you know, can you have a consortium of funding so that everybody's chipping in to pay for your facilitation so that
yeah, I suppose that's anything like that's possible, I guess. That wasn't, I mean, I went out there 2 or 3 times. I think it was maybe a max of 3 times. And then it was over. It was thank you very much. That was fun.
did
And
they
that
do
was
anything?
that.
Did they do anything?
It was a long time ago. That has to be going on 30 years ago. It was right after the Earth Summit, the Rio Summit in 92. Everybody's into sustainability. So this might have been 94, 93, so on the order of 30 years ago. I don't remember. The people who brought me in are retired and dead, so I can't really, there's probably nobody I can ask even. So but all I'm saying is it's not like this clean, crisp 2 + 2 is 4 thing. There's a lot of sociological stuff that goes on, social psychological stuff that goes on when you're really doing this with people who know a lot about the system, right? So we're going to say, turning back to the problem at hand here, we're going to declare that better means making the orange curve lower. Okay, the policy recommendation that generates the lowest total heroin-related crimes will declare the best. But we acknowledge we could probably have a more sophisticated definition of what that means. And of course, you know, if you're being hired by the head of the methadone clinic, it's probably the policy prescription that yields the most addicts who are in rehabilitation, or I guess you're never cured, but you're not using anymore, would be more likely what it would be declared the best policy, not the heroin related crime things, although one would help influence the other. Right? Okay.
On that note, just one question here.
Yeah.
To me, stating what success would look like, that in most cases, the most desirable thing would be to address the root cause, which is, in this situation, the demand by the addict. And if you can get an addict and address their root cause of, you know, family dysfunction or whatever, and give them this strength and stability socially so that they are resistant to the invitation of heroin. I mean, don't you want that, what this looks like, to be addressing what everybody in the room says is the root cause?
Right. But in terms of the time shapes, if that's our reference mode and we're trying to make things better, we have to know what better means. Okay. Less to the mayor, it might be, I have to spend less of my budget on this problem. You know, the budget is fixed and I have more money for paving roads and giving crayons to the kindergarten kids if I don't have to spend as much money on Narcan and police overtime to deal with drug raids and whatever. So to the mayor, it might be we put $1 costs on the police officers and all the stuff that's happening. The policy prescription that yields the lowest cost is the winner. Now, along the way, you presumably have less heroin on the streets, more addicts in rehab or whatever. But it just depends on the client and what they regard as, or it's multi-attribute. Yes, we want a low price or cost. We want more addicts in rehab. We want fewer dealers, whatever. There's a laundry list of stuff. We'd like all of that. Of course, you want low crime, good schools, low taxes, lots of open space, opera houses. You want all that. But a lot of times, more of one means less of the other, right?
Right.
So that's why you try and capture like what's important to you, the client, and we'll see what we can do to make whatever's important to you better. That's why it's subjective. It's not, and so, sometimes there's consensus. Sometimes you go in, it's not like Truckee Meadows tomorrow and all that, where these people want to strangle one another. Sometimes it's like in 7 seconds, everybody agrees. It's like, okay, this is easy. And off we go. And other times you're like tearing your hair out trying to get these people just even to listen to you, because they're yelling at one another and they're all amped up. And, what, by the way, just as a sidebar, I don't want to dwell too much on it. We'll never finish this, but what I did with Truckee Meadows tomorrow and the real estate people is I said I was going to do something very different. And I was like, this is never going to work with these people. They're out of their minds. So I said, let's play a game. And I whipped out fish banks. We played fish banks. And I said, you guys want to beat each other's heads in? You guys can be a fishing team and you guys can be a fishing team. And the politicians are, and let's see if you can win. And so it was funny when they wiped out all the fish, as they inevitably do, although it's not mandated. It doesn't have to happen. The real estate people said, we didn't do that. Pollution killed the fish. I said, there's no pollution in the model. Silence. Pollution killed the fish. I said, there's no equation in the model that has a P in it. It's not in the model. It's impossible. Silence. Pollution killed the fish. Nothing I said. Pollution killed the fish. They didn't do it. Pollution killed the fish.
That's denial in the first degree, isn't it?
So what do you do now? So when people like that, what are you going to do? I mean, it's, they just didn't want to hear it. Right. So that was the toughest audience. That and the intelligence agency people they were a tough audience. They were super tough. And then the White House staff, they were tough. Those are my 3 toughest audiences ever. You survive those guys. Teaching undergraduates is nothing. All right. So now, if you might notice, I've pulled up Stella here. Now, some people will have Stella up real early, and all the stuff I was hand drawing, they would be putting right into the software. A lot of people, if they're facilitating for groups of experts and stakeholders, will use other techniques. There's a famous technique called the hexagon method, where you ask people to take, I've done it, but I've never used you can buy these hexagon shaped Post-it notes. I've just used Post-it notes because they're cheaper. But you tell them, after you get a problem definition, this problem statement on the board, and you're trying to find out what variables you want to graph to make a reference mode, you get them to take Post-it notes and write one important variable related to the problem statement on the Post-it note and stick it on the board. And they do that with relish. And there's Post-it notes everywhere on the board. And then you say, go up there and Post-it notes variables that are related to one another, unstick them from where they're at and stick them, sort of make a pile of the similar related stuff. With the hexagon method, you join the edges, and you make this big, but at any rate, what happens is they end up being the sectors of the model with the important variables in those sectors defined. We kind of did that, but I was hand drawing it and asking you to offer suggestions. But that's one way to do it in sort of a group setting. And that works pretty well. People seem to enjoy that. What's funny is you give them another chance after they put everything up there and they say, make piles, and they'll go up and then you say, all right, I'll give you one more chance. Go up there. Everybody look at it carefully. Change your mind if you want. So they go up there, they're scratching there, then they start switching stuff, and then other people go, and they switch them back. And you get this fight going on about where, and I'm like, we can, I get it. relevant to both sectors, that might mean the sectors are connected. You pick one. If I got to flip a coin, we flip a coin. It's going to be in this one, not that one, but they're interacting. And whatever. But it's kind of a fun exercise. And you see, this guy puts it over here. This guy gets up and he sees it happen. He gets up from his chair and he puts it back.
Funny.
So you get some of that stuff happening, the interpersonal stuff happening. All right, but anyway, so you can do it on the blackboard, whiteboard, whatever. You can put it right into the software. You can use techniques like the hexagon technique I just described, whatever. To each his own. And sometimes you got to read the room and figure out with this mob I got here, what's going to work and what's not. Or you're just doing it for yourself or your dissertation or whatever, and you're just talking to people one-on-one, maybe one-on-two, a modest group. You're not necessarily convening a room full of experts and stakeholders, although Jay did that with the urban dynamics model, right? John Collins said, when do you want them here? And he had all the people. So it just depends on the circumstance. All right. So in Stella, we have two sort of rectangular icons here, right? One is for stocks. And we said there's actually different kinds of stocks in the software. We're not going to worry about these other ones in this class. The only one we're going to worry about is this one. That's the traditional stock, right? And then there's another rectangular shape over here that has rounded corners, and that's a module. Okay, so they're different. These two things are not the same. The modules, if you click over here, it also says sectors. I call the modules sectors, if you remember. Sectors are a legacy thing from older versions of Stella. I'm told they're going to eventually go away, but since they want to make it backwards compatible, the latest version of Stella, you should be able to open accurately a model created with an older version. They're keeping them for the moment, but I think of modules as sectors, even though they're not technically sectors. So we had specified two sectors, right? We said the dealer sector and the attic sector. I'll get the spelling right here in a minute. That figures. Okay. Notice we have the chi-square symbol here. That's the model view as opposed to the map view. Map view says hide all the warning labels because it freaks people out. It's a legacy thing. The model view says put up the warning triangles if something is not right. So we're going to have these two sectors modules interact, and because we're in model view, we get the warning triangles saying, all right, you said something is interacting here, but you haven't told me what, so I'm going to start warning you that you got to fix this. Okay. All right, now in the attic sector, we might start here first, and I mentioned we might start with a constant number of attics. Okay, now often a constant, a parameter is just done with a converter over here, a circular icon. But often you're thinking ahead when you're building a system dynamics model, saying, what am I going to do here later? So sometimes a more experienced modeler knows that they're going to be circling back here, and so in what they're going to do, so they're going to kind of save themselves a little work. So we're going to, instead of making this a converter, I'm going to make it a stock, but I like to initialize my stocks outside of the stock. You might remember me saying that earlier. So over here, attics initially is initial attics, and those can be people. And I'm not sure how many attics to put in here initially. Obviously, if you had real data, you'd use that. Or an expert can tell you, I put in 1,000 here for this. An expert could tell you, right? But I just use clean numbers, modest size clean numbers usually. I said 1,000 there. Okay. So let's leave that be for, we got to pick one. So let's work over here and let's make that just constant for the moment. Now, let's see. Going back real quick over here, that's what I want to do. These time shapes are mostly things, if you notice my little stars here, whatever, they're mostly things that are taking place on the dealer side, right? So that's why I'm suggesting we start on the dealer side of the ledger. Nothing magic about it, but that's my thinking. Okay. On the dealer side over here, one thing we can do is we can take a stock and plop it down off to the side here, right? And I'm going to right click and I'm going to say accepts input. It's a stock that accepts input from another sector. And then, let's see. Oh, sorry. Got to go back here. I needed to say right click, my bad, module provides output. So the addict stock in the addict sector is going to provide output to other sectors. And over here, we said that's going to accept input, which is specifically, I want it to accept the addicts from the other sector, from the addict sector. Notice the dotted line. So the original is over here, and it's shooting its information by this telephone wire over to here. It's dotted, meaning that's not the original. And notice it even tells you it's addicts from the addict sector. Everybody see that?
Mm-hmm.
Okay. All right. So if we go back to our reference mode and our story here, right? We started out by saying with the red curve here, that's dealer heroin, and we're going to start in equilibrium, right? And then there's going to be a shock and so forth. So let's keep these concepts in mind and go back over here. Dealer inventory, dealer heroin inventory. Is that a stock or a flow? Here's a hint.
It's a stock.
Yes, and I've given you a hint because I put it up there. Yeah, it's a stock. An inventory of anything will almost always represent by a stock. Nothing in the rule books that says you must do that, but it makes a lot of sense, right? Okay, dealer heroin inventory. If you have a stock, there has to be at least one flow that flows in or out, right? Or it could be a net flow, I guess, right? So are there any flows that leap to mind, either from our brainstorming or other information you might have in your head about this problem, that we could use to change the amount of stuff in the heroin stock, the dealer heroin inventory?
I don't think we really talked about that, have we?
Well, you might want to look at the graph in front of you.
Okay, dealer heroin inventory. Oh, police interventions, I guess, would impact the inventory.
Well, what would be a flow that directly changes?
Arrests, seizures, seizure rate.
Seizure rate, yes. Sehr gut.
I was thinking about manufacturing rather than just getting your hands on this stuff.
Okay, so the idea here is when you identify a stock, almost always it's going to change. and it's going to change by flows. So there's got to be, there almost always is one or more flows that will directly flow into or out of this stock, of any stock, right? So, I mean, this one, no, but we said we're going to circle back to this guy. So it's just sitting there, but we recognize that that's not the end of the story here. So you said, Suzanne, that one thing that would be a flow that would change the amount of heroin inventory would be the
Seizure rate.
seizure rate. Okay, yes. What else would change? Now, we didn't necessarily have it in our reference mode, but that's okay. What else might change the stock of heroin inventory?
I mean, the staff,
Dealers.
They should
staff, access to manufacturing.
Yeah, like the transportation from the source zones.
Okay, so you're saying new stuff coming in.
Right. Acquisition rate.
All right, so heroin comes in from the dealer's dealer. There's a supply chain management issue going on here, right? Okay,
By Guido.
okay. What else? Is there any other things that would change? Heroin comes in from the dealer's supplier. It's seized by the police. Does it go anywhere else?
Like other places that their inventory is going?
Yeah.
Oh, to the addicts.
Yeah, absolutely. The heroin sales rate, right? So my style is I'll select and copy this and say initial, whatever it is. And over here on the right, the initial dealer heroin inventory is initial dealer heroin inventory. And we said that's bags, or the article said that's bags. This is going to be in bags, right? And let's leave this blank for a minute here. We're not going to specify that quite yet. Let's do this. Where does the heroin go once it's sold? You know, based on our brainstorming.
It's consumed by the addict.
Yes, but based
Goes
on
to their-
brainstorming. So the right-hand side of the figure is the addict sector stuff. The left-hand side is the dealer sector. So you buy it. Let's say we're not addicts. Let's say we're buying bottled water. I buy it from the store. I take it home. Do I suck down 24 bottles of water?
No, but it's the supply is gradually consumed. So
Okay,
it's
so the supply on this screen, what's that?
The heroin addict inventory.
Yeah, exactly right. You take 24 bottles of water, you put it in your closet or in your refrigerator or whatever, right? And then you slowly consume them. So you have an inventory, right? Yes? So we said that that was part of our brainstorming. Now, that doesn't mean it has to go into the model. But let's just, for the sake of argument, so we can say, right? And what would be some flows in and out of here?
Use rate.
Okay.
And acquisition rate for is going to be your inflow.
Okay, so there's going to be an inflow here, and that's going to be purchase rate. Okay, call this. So let's right click here and say module accepts input, the purchase rate. And this is going to module provide output. So the sales.
Hey, where it's going on that drop down screen, I couldn't see that.
Sorry, what?
That last one, does it say like where you're sending the output on the drop down screen? I
Yeah,
couldn't
so
see.
over here.
Yeah.
So it says module provides output.
Okay,
Doesn't
but
say
then
it doesn't say where it's going. It's just saying it's giving to the world
okay.
its flow.
So then it's on your selection list in the other sector.
So, well, as long as there's these wires, as long as there's a wire going here, yes. No wire, no, oh, hit the wrong button. Sorry. So over here, I'm going to hit the right click and say module accepts input. It's accepting.
Okay. I get it. That's a
the
new
sales
feature
rate.
for
Okay, now, okay. Now I don't like this, but this is, a lot of people do this. I'm going to undo this because I like this purchase rate here. Okay. Instead, what I prefer to do is I'm going to say, I got a converter here, accepts input, converter.
Oh, I see. Yeah, that's brilliant.
And then it goes like so. This way here, you see, for transparency purposes, that the sales rate from the other sector is the purchase rate here. And the purchase rate is simply the sales rate. Right? And you can see it's already in bags per months. I'm going to make this month. Okay. All right. You don't have to do this, but I like to do that for whatever reason. You just do. Okay. So
it just
now,
makes much clear.
You can see how these two sectors are there's stuff going back and forth, right? Okay. All right. So we're going to have to do something with this now. Okay. So for the moment, let's make this 0. Turn that off. Seizure rate is off. Okay. What do I see here with my little system dynamics brain? Okay. So this is kind of, Ashley, you kind of asked before, like if different modelers are building a model of the same thing, would they reach the same conclusions, even though the details of their model might be a little different? And I said, pretty much, yeah, because you kind of all are trained the same way and you sort of think the same way. So over here, what I see is there's an ordering function, or the generic structure molecule. It's really bigger than a molecule, it's a generic structure. That leaps to mind is an ordering function, an inventory ordering function. A simple one. We don't have backlogged orders. The addicts usually don't place an order. I suppose in the movies sometimes they do, but usually they just are all shaky and they go, I need a fix, like right now. They don't place their order and wait for delivery, like from Amazon or something, right? Different situations call for different pieces of structure. So this would be a simple ordering function. Okay, so what's the system dynamics solution to something like this? Well, we could say we want let's see, I'm trying to think of the best way to do this. Let's call this desired heroin sales rate. So notice I have the actual heroin sales rate and I have the desired heroin sales rate. Okay. And what is the desired sales rate?
That's what the addict would craves. That's their,
Right.
they want to get their fix when they want it. And it's,
So it would be the number of addicts times the bag. I guess we got it in bags per addict per month, right? So I don't know what that, we'll just make this 4. This would be bags per addict.
kilograms.
Yeah, but the article says bags.
Okay.
So bags per addict per month times addicts, or we said people, bags per people per person per month. I think by default, Stella knows people are persons, bags per person per month. So if you multiply those together, number of addicts times the bags per addict per month is the number of bags per month that are desired, right? So many addicts and each one needs so much every month means you need that much. That's what they'd like this flow to be, right? And we're going to say that here, the actual sales rate is going to be the desired sales rate, but with one modification. What might that modification be?
Availability.
Yes. So if there's no heroin inventory, you can't have any heroin sales. Doesn't matter what the addicts want. It's what they can get. Or there might be some heroin inventory, but not enough to satisfy everybody. So it has to be rationed, right? So what we need is first order control, right? We have to say, look, when that stock is empty, stop selling heroin to the addicts because there's nothing to sell, right?
Right.
So typically we would use a table function for this. The effective heroin inventory on sales. And so this would be the desired sales times the effect. So if the effect is 1, then actual sales are the same as desired sales. And think about it. We would typically plot both of those things on the same graph on the same scale, desired sales and actual sales. And if the two lines are on top of one another, you're selling your customers are happy, at least with the quantity. It might be poor quality or something, but they're happy with the quantity, right? When you're starting to run out, right, either because you got supply chain problems or there's been seizures, you have to start rationing. And when there's nothing in dealer inventory, the effect should be 0. It should be desired heroin sales times 0. Shut it off. There's nothing to sell, right? Yes?
Right.
Okay. So, the question then becomes, how do you determine, table functions always have a ratio on the x-axis. So we can have a desired dealer heroin inventory. Okay. So often when you have a stock, you will often have a desired value for the stock, a target, a goal for the stock. And we will often explicitly represent that idea in a system dynamics model. Okay. So you want to always think about, is there any, either the target could be given by nature, by somebody else. For a pendulum, the target is to hang straight down. That's a physical thing. 98.6 in the human body is set by nature, whatever, you shiver or perspire to try and keep it there, right? I might have a goal for my grade point average, a target for my market share, whatever. So when you're managing inventory, you typically have some idea about how much stuff of your whatever you're selling you want on hand. And when you don't have a lot on hand, you start to get antsy, like I might run out, right? So there's some kind of desired level of heroin inventory. When you play the beer game, there's a desired amount of beer in your inventory box in front of yourself, right? So if we go over here, we can say, all right, the ratio here is going to be heroin inventory divided by desired heroin inventory. And to be safe, because desired inventory is not going to be a constant, I use the double slash, the safe division. So we don't want this thing blowing up if we if the denominator happens to go to 0. Now, by the way, this is a class exercise that we're doing here. So I'm not testing a lot of these pieces of structure in isolation first, in the interest of time, number one. And number two, once you know how these pieces of structure work, you don't have to retest them every time, because you know, and I know. But really, you should be testing some of this stuff little by little, piece by piece, as you go along, because I kind of know what each piece is going to do already. So just saying it might not be as smooth, if you want to call this a smooth sort of laying out of what's going to happen here. But anyway, so having said that, so you specify the ratio on the x-axis, right? So when heroin inventory is at its desired level, the ratio is 1, all good. When there's no dealer heroin inventory, when 0 in the numerator, there's nothing to sell, shut it off. Then you say, all right, I'm going to go to the graph, and I want to make it a graph. And I'm going to use a canned function here. I want to go from 1 and 1. There's that canned function. But I don't want to start the second you drop a little bit below what I want ideally in inventory. I don't start cutting back probably. I usually wait. So I would probably make it look something like this. And I probably want a few more data points here to smooth this out. Something like that. But notice I got 1, 1 and 0, 0. And then I'm still at, as I drop below 1 on the ratio, I'm still at 1. I don't start cutting back until, maybe halfway through I have half of what I want. And then I start to cut back. But you can ask the manager, the drug dealer, the managers of when do you start cutting back? Okay. Now, desired heroin inventory. How do we come up with the target here? Well, there's a couple ways of doing it, but I'm going to have you recall when we were studying steady state error. Remember, we tested that expected order rate structure, and we had the railroad tracks in response to the ramp function. We said no good, right? That you're never even though it went for 1 billion weeks, always raising by 20, the expectation structure never expects that. So something's not right there. And then we said steady state error occurs when the system locks in and at least one negative loop is not at its target. But it doesn't, it's not just in a growth situation. You could have, I showed you an inventory structure where you had horizontal railroad tracks. And we said, I showed you a cure for that, right? A fix. And the fixed involved, let's use that. The fix involved molecule number 3. So we'll call this average, the average heroin sales rate. In this case, we want a biflow. And we've got one of these moving averages here. So the change in the average heroin sales rate. So far, so good.
Yep.
And that molecule number 3, it's a proportional control structure. So the average doesn't change instantly. Make this something like 3 months. And typically don't like crossing wires if I can help it. So the equation here, if you remember that molecule and remember that steady state error thing we did, was target minus stock divided by tau. So you remember the average doesn't change when the new number coming in, the next sales rate number, is the same as the average. You have a 4.0 grade point average, you get another A in a class, you get another 4, doesn't change your average, right? So that would be an equilibrium or at peace, or there's no pressure for change, right? And I'd like to initialize outside here, but there's really no need in this case. So the initial value of average of the average heroin sales rate is the heroin sales rate. It starts that way. So this would be bags per month. So over here, this is going to be bags per month. And this is like acceleration, bags per month, meters per second, right? This is should have said MO there. Okay, so far so good. You kind of remember that?
Mm-hmm.
The steady state error thing.
Yep.
So then we said in a system dynamics ordering function, there's a pattern. Okay. We're going to do a modest pattern. There's a more sophisticated one, but that's for the advanced course, the next course. So what we'll say is correction for heroin inventory. And again, if you refer back to that exercise we did with the steady state error case, you'll see that it's the exact same thing. So we'll make it something like 3 months. And the equation here, not surprisingly, is desired target minus stock divided by tau. So it's the exact same thing, right? Same thing over here. Target minus stock over tau, molecule number 3. Over here, target minus stock over tau, molecule number 3. Doesn't exactly look like molecule number 3. This one does. That one looks like molecule number 3. Same idea here. It doesn't look like it. It doesn't have to look like this, right? Okay. And just like in that steady state error exercise, we said for system dynamics ordering function to work properly, we need the max of 0 or correction for inventory plus average sales. And I got to look at my parentheses here like so. All right, so you might, if you go back and you'll see, remember when I put the step function in the sales rate and it just stepped up, and then the acquisition rate just stepped up automatically, and we said that doesn't make any sense because the step was a shock, it wasn't anticipated. So we averaged it, we smoothed it, right? So the idea is you want to correct for the difference between what you want and what you got, the proportional control structure, and you have to replace what you're losing. That's how we fix the steady state error, right? Exact same thing. Okay. Now, how about this desired heroin inventory thing? Well, again, the generic structure is as follows. And then we'll at some point, we're going to actually run a simulation here. So we have normal heroin coverage. So in inventory management, there's the notion of coverage. My brothers and sisters in economics in the national income and product accounts call it the sales to inventory ratio.
Oh, I remember that.
Remember we talked about Little's law?
Yeah.
Average residence time of a unit in a stock. Well, you could say normal heroin coverage or desired might make more sense. So coverage is a time idea. It's not a bag idea. It's a time idea. You might say we want 1 month worth of heroin at the rate it's leaving. I want 1 month of the stuff around, and then I'm confident. Okay, so you could plot on the same graph on the same scale desired heroin coverage against the average residence time here. If you use Little's law, and when they're the same, you're good. You're at your desired value. So this is in terms of time. This is in terms of bags per time. So bags per time times time is bags, which is what I want. So it would be average sales times coverage. And that would be bags, which is what I want. Okay. Oh,
Coverage is ratio of coverage. It's inventory to sales. Is that right?
If you're using Little's law, right? Yeah.
Okay.
And over here, see what it's given me is a circular error. So trace it around. Average heroin sales is used to compute desired sales, which is used to compute the table function, which is used to compute this, which is used to compute this, which is this. So you're using it to compute itself. So in other words, the initial value here is average sales rate, or excuse me, as sales rate. This initial value is this, but this is used to initialize this, but it's used to create this. So that's a simultaneous equation situation. So it's no good. It's not going to let you simulate. So you have to think in equilibrium, what should the heroin sales rate be? In equilibrium, what should it be? When this table function that's involved in the circularity is taken out of the equation, or its value is 1, it's not doing anything, it's dormant. What should the heroin sales rate be?
1,
The effect
1,
is 1. Okay.
yeah,
So if the effect is 1, then the heroin sales rate is equal to the,
equilibrium. It's in steady state, right?
yeah, but it's equal to what?
The
This is 1. This is
acquisition,
look at the equation. When this
Right.
is 1, when that's 1, heroin sales rate up here is equal to,
1,
it's not equal to 1. The table function is 1. When the
Oh.
effect is 1, the sales rate is equal to the desired sales rate. The desired sales rate is calculated without any of these things in the loop. So you can use that. So we can go up here and say, it's not the heroin sales rate. Let's use the desired heroin sales rate. And it's not involved in the loop.
oh,
But
I
in
see.
equilibrium, which is what we're after, that's what it's equal to. The sales rate, which gives us the problem, is equal to the desired
Right.
sales heroin, which is not involved in the loop. So we can use that and looky, boom, we're good.
Solve the thing. Okay. I
Problem
get that.
solved. And then finally over here, initial dealer heroin inventory. It's not going to let me do that. I thought it would. Fine. Then I'll do this. The initial value of inventory, let's call it, is desired because we want it to be in equilibrium. So this initial value is the desired value. Okay, I don't see any issues here. What do we got? There's still an issue here. We could say there should be a desired inventory here. Let's just make it 0 for the moment, just to make that 0 for the moment. Now everything is cool. I mean, we can run the thing now. So we can run a test here. What time is it here? 8:03. So we're getting towards the end of our session. I know this is painstaking, but I want to express my, thoughts as I'm doing this. And of course, I know certain generic structures here. So it wouldn't be quite as painless if you guys were doing it, but you can see the sort of the thought
Yeah.
process. So what I would typically do here, I would be testing, if I was more of a novice, I'd be testing earlier. Also, just in the interest of time, but the sorts of things I would do, I would put on here desired inventory as well as inventory. That would make some sense, right? You could put on the desired sales rate, the actual sales rate, which, is not going to be very interesting unless there's a seizure or a shortage or something. But right now it's, just for the purposes of showing you. And then the acquisition rate. So we've got the flows here. The seizure rate is 0. So we're not going to worry about that. And I think it said 48 months in the newspaper article, something like that. So as you can see, we're in equilibrium. Nothing much is happening here at the moment, right? But that's good because we want to start it in equilibrium, right? We said, we want to start in equilibrium here and then shock it out with a seizure, knock, knock, and boom, they come crashing in and seize, right? So how do we represent that? Well, this thing is going to have to be turned on, right? And then we'll see. So I'm at 8:05. So what are your thoughts here? Do you want to just leave it here and then we'll resume next time?
Oh, that sounds like Batman. You're gonna find out what happens next.
Oh, the next
time.
day. Yeah. Yeah. That was
Uh,
left me hanging. Yeah. They were always in some weird thing. They were like tied upside down, hanging over a boiling pot of oil or
Yeah.
something.
I'd be
Same
okay
bad
with-
time, same bad channel. Somehow they
Yeah.
always escaped the next day, the next episode. But
Mhm.
Batman and Robin. All right. So in the interest of time, we'll leave it here.
Okay.
So when we resume next time, we're gonna specify how the police are gonna seize things, okay, and see what happens, right? And if it looks about right, there's nothing goofy, then we'll say, all right, we gotta proceed, keep going, right? Okay.
That sounds good.
Okay, cool. So with
Sounds
that, let me just stop sharing here. Here we are. So we're making good progress. I think if I'm going too slow and you're tearing your hair out, let me know. But usually people like to see step by step in detail how somebody's doing something. Because the thing we always heard at the SD Society was, why don't you have 5 expert modelers sit in a room with cameras and an audience and give them a problem they've never seen and watch them build a model, or 3 expert, whatever, and it's like, yeah, the sausage making is often ugly. That might not work in real time, particularly in an hour and a half, 2 hour, even a 2-hour session. I'm not sure how far you get, but the notion of having someone with experience think out loud and show people how they're, now this is a little contrived, so it's not like I've never seen this before and I'm thinking out loud. So it's not quite there, but you get the idea that people have always said they want to see, what are you thinking about? How did you know that? How did you know to do that? What were you thinking of when you saw that? I didn't see that. How did you see that? So I try to express, what am I seeing? What am I thinking about? What is it? I just know there's a generic structure that I can use here. Right. And so if you don't know that generic structure yet, you got to learn that. But since I know that, I just use it. I don't try and invent it. That sort of thing. Right.
Right.
Okay. So
Right.
that's the idea here. So it's, is what it is. Right. So it's not the most elegant of processes. It's an iterative thing, and then there's mistakes are made, and and whatever, minds are changed. You do all this work, you spend 75 hours, and you show the client, and they go, no, that's not right. Try again. So that's just the nature of how this works, right? So
I think it's very helpful. I don't think you're going too slow, because it takes some time when, at least for me, not being familiar with the structures. I mean, I found myself saying, oh, we need to do a gap analysis here. What is going to be, where's our rheostat going to go to achieve? So I find myself in my head trying to solve it as you're talking slowly. I may not have the right words, but I know that there's a structure out there to help assess what the gap is, or, I just don't know. I haven't memorized those structures yet, but I imagine it's like learning a language. Once you get comfortable with those things, you get it right, how to solve the problem.
Yeah, like anything, the more you do it, the more you use it, the more familiar you are, and the more you can just grab them and use them, on and on. So, okay. All right, good. So, good job. We'll leave it there, and we'll resume next week.
Okay. Thanks, Mike.
All right. See y'all.